Hello everyone, we're going to take a look at the new mill toolpath today just to give you a rough guide on how to use it and what some of its features are. We'll start by loading up the Roadrunner file. This toolpath, by the way, is in version 1.71 onwards. As you can see, when you load the file, there's a few differences from the old toolpath. First of all, your crosshairs, these purple colors here, originate at the tool and show the position that you're in. You'll notice something as I jog my x-axis back and forth here. When the x-axis goes off of the job size, the line turns red on the job to let you know that the cursor is far away in that direction. So, for example, if I jog the X and Y off screen, you don't have a crosshair anymore, but you do know by looking at these two red lines that the crosshair is down this way and over this way. You could, of course, hold down your Shift key and zoom out and see where the crosshairs are if you were curious. Double-clicking the screen will take you to a top-down view as before, and you'll notice on the top-down view when I rotate it, there is a transparent piece of glass on the bottom which makes it easier to tell that you're looking at the bottom as opposed to the top. Another notable feature is that we have a tool right here. This is an iconized tool. It is not meant to really represent any particular tool, but if I zoom in, you can see it is really a transparent, sort of a small tornado in transparent color, so you can see your toolpaths behind it. This tornado can be followed if we click the job follow mode. Now if I were to run this file, the toolpath will continue to display the tool as it cuts the job. You can turn off jog follow at any time and the job will continue, so you can see some detail perhaps that was cut. Hitting jog follow again and you'll begin to follow the path. You'll notice when I'm following the path that I no longer leave a green line behind us. These are technical requirements. Unlike programs like ArtCam and other graphical display programs, we have a controller to run here and time is finite. So we have to optimize time as much as we can, and we play a lot of tricks in order to display all the fancy stuff you're about to see. So one of the downsides to that is if you're in jog follow mode, all you're going to see is the last move to move distance. This will tell you how fast the tool is moving versus how fast the program updates. The tail part of this line would be the last known location, and the tip would be the present location. Turning off jog follow though, and we can leave the line behind. Now you can't zoom or pan when the program is cutting because we don't want to interrupt the pulse stream. But you can feed hold, and at feed hold you could zoom out in the normal way. You can pan also, and it doesn't matter what angle you're at, the pan works perfectly to get you centered. So double-clicking takes you to your top-down. Double-clicking again takes you to an automatic ISO view that you know you'll always go to, so it's kind of quick to just click back and forth. You can do that also while you're cutting. If I start the job again, we can see now we're cutting the job. A double-click takes us to top-down, and a second double-click takes us to the job. Now I'm going to hit feed hold for a second. One thing you'll notice here is that your eye will be drawn to a movement going on the toolpath screen, and that's because my spindle is on at the moment. And as you can see, the spindle is rotating very slowly. It's actually going at 1/8 speed. If I was to bump my spindle speed now to my maximum pulley speed, you can now see that the spindle is rotating and shows us graphically, even if we're in a top-down view, it's always obvious to you that your spindle is turned on. If I turn off my spindle, you'll see it comes to a stop. Turn my spindle back on and restart my job. Now you do not need to regen this display after zeroing your X, Y, and Z coordinates. However, there is a caveat to all this. This display works very well, and I don't think that you'll have many problems with it. But one of the new rules is you cannot have an A in any of your rotational axes. If you're not using them, you must zero them. To show you an example of why, I'm going to put 45 degrees into my A axis, which you can't see me do, but I just did. I'm now going to regenerate the display. What you'll see is that my toolpath is way down here and rotated at 45 degrees. This is because this toolpath display takes into account rotational changes. So make sure when using this version onward, if you want a proper display, that you zero your rotational axes before you load your job or afterwards and then regen. You'll have to regen if you reload a program and your rotational axis is not zeroed. So take note of that particular issue. And here's why. I'm going to load a file now, which is a ring that someone sent me earlier this week for support. And if I double click and look straight down and then double click to ISO, you can see that what we see is the actual ring that this person has sent me. There are a few rules to be followed here which may morph a little bit as we get a little bit more complete the work on the rotational tool path. At the moment, for example, you'll notice if I look at this side on that my tool is not pointing to the top of my rotational axis. One of the things to take note of when using a rotational display, you'll notice the display pretty much automatically came on. However, in the toolpath settings, if I just drag this up here, you can see that we have an A-axis offset. Mine are set to 0 at the moment. And what that's telling the system is that my center of rotational axes is at machine coordinate 0, 0, 0. This means the display is going to match up my current machine tool position with that axis. So you should enter numbers in here which are proper for your rotational table. That will make sure that the display lines up with what you have selected. Now, a couple things you'll notice about this display. If I start to jog my A-axis, you can see the display itself rotates. This is because you're meant to see on this screen exactly pretty much what you see on your table, the A-axis rotation rotating as the job gets cut. This is a ring, as I said, that somebody sent me earlier. I'll show you it running. I'll just hit cycle start here before we do anything else. You can see the spindle turns on. It rotates to 0, the tool goes to the top, goes down, and starts to cut the ring. This ring is being cut in the x-axis across the wax cylinder, and you can see every time it takes a path, it rotates the ring and takes another path. So what you're seeing is the actual cut process involved in cutting that ring. This display is pretty much automatic. You shouldn't have to do much to get a good display, but we're working on making it more bulletproof at the moment. So I'm going to load a different file now, one which is a test file written by Brian to test the system. This is a test that was written just to test the rotational. You can see that it's a rotational job with some features in it. And if we look at it top down, you can see it's actually, from a top view, quite a convoluted path. And this is meant to be solely for testing, so expect it to look a little strange. I'm going to rewind the file. Now what you can see as it cuts, first thing, we're rotating to 0 to start at the yellow dot, which is our start point. And we begin to cut. Now you'll notice that the axis is cutting in the A, the X, the Y, and the Z all at the same time here. What you may not be able to see real close, and I'm going to feed, hold, and zoom us in on that so that you can see it closer, is that the tool head itself is rotating, because this is a 6-axis job. So the tool head itself is rotating to the appropriate vector to show you which way the tool would be approaching. This doesn't mean we do 6-axis toolpath compensation, by the way. This is just in preparation for it at some point down the road. Here you can see we cut a circle and tilt the tool as we cut the circle. And now we cut the rest of the way around the object. I'm going to zoom this out so that you can see that somewhat better. And all this particular job does is repeat. It gets to the start point and it rotates back to an A of 0 and starts to cut the job again. But the reason for this test file is just to show you that you can do various features and so on the A-axis, and you will see a recognizable display and something that you would expect it to cut. Again, the A-axis display is a little bit harder to use at the moment because you have to understand something about offsets and where you're positioning your rotary table. But as long as you position your rotary table in the machine coordinates that you've specified, you really shouldn't have too much of a problem in terms of making it work. And remember, it's important to zero your rotational axes if you're going to load another job. And we'll load the Roadrunner file again here. And the Roadrunner file loads up and is ready to go. Jog follow mode again. And drop off from jog follow. If you do display mode, you have to stop in order to do it, of course. But you can switch to a job. You can see the box representing the soft limits of the system, and your job is in the middle. My soft limits are set rather large at the moment. You can see that they encompass all axes in a cube. And that's it. I just wanted to give you a brief tour of the Toolpath so you'd be aware of how it works and what the various things on it mean. And you'll see this Toolpath as it stands in 1.71, which should be out this week. Thanks. Have fun.